Okay, it's 14 hours. Good afternoon, good morning, everybody. Thank you very much for joining. Welcome to the second day of the Cambodia Waste Summit 2020. Warm welcome especially to our guests from the Konrad Adenauer Stiftung and the Global Business Network. My name is Aurora Rios. I'll be moderating today's afternoon session. Our topic is why is it a good idea to separate waste in an industrial scale? Before we begin, I would like to mention some recommendations and guidelines for today's session to make it most enjoyable for all participants. Please observe them throughout today's session. The first one is, if you haven't already, please deactivate your video sharing function. This is to make sure that we can see the speaker's presentation in the highest possible quality. Background noise, and we can all hear the speaker. Thank you very much for that as well. If you have any questions or comments, kindly use the Microsoft Teams chat function, and we will try to address all of these at the end of the session. Please note that the contact information of the speaker and organizers will also be provided, so please know that you have the possibility to take note of this. And that said, we can continue. I would like to give the floor to Dr. Bianca Buntit.
Okay, thank you, Aurora. Good afternoon, ladies and gentlemen, or good morning to Germany. I know that it's still quite early in the morning in Germany. I would like to welcome you to the European Circular Economy Business Panel and Matchmaking event. My name is Bianca Buntit on behalf of German Development Corporation and GIZ. I'm currently working at the German Business Group Cambodia, which is one of the founding members of the European Chamber of Commerce in Cambodia. This panel is hosted by Black Forest Solutions, which is a consultancy company from Germany, the GIZ Global Business Network Program, the German Business Group, and the EuroCham Cambodia. I would like to thank the main organizers of the Waste Summit, the Konrad Adenauer Foundation and COMPAT, for giving us the opportunity to organize this business panel. Furthermore, I would like to really thank Black Forest Solution for organizing the different sessions. Thanks to their excellent network to the sector, to the waste management sector, they managed to attract many German and other European companies to join the different sessions in the following days. And I would also like to thank our speakers from Europe. Aurora, if you could please share the next slide. Thank you. So why have we organized this panel and matchmaking event? We all know that the amount of untreated waste in Cambodia is tremendously high and that it's becoming a serious environmental and health problem in the country. At the same time, Germany is a world market leader when it comes to sorting technologies, treatment of waste and recycling technologies, and actually circular economy is a top priority for environmental policy in Germany. And as Sebastian has mentioned yesterday as well, waste management has evolved into a large and very powerful economic sector. There are more than 270,000 people working in more than 11,000 companies with an annual turnover of around 70 billion euros. So these figures were mentioned yesterday as well. We all know that the framework conditions in Germany and in Cambodia differ quite a lot. But still, we think that some technologies or approaches, solutions could also be transferred to Cambodia. Therefore, we've organized this panel. It should be like an ideas generator for waste management solutions in Cambodia. We've invited several speakers from German and other European companies, startups, social entrepreneurs, and they they will present their technology, products and services. As mentioned, it's meant as a platform or as an ideas generator for maybe project development platform as well, and we would like to organize matchmaking events between Cambodian stakeholders and European private companies after the different sessions. And finally, I would like to mention that German Development Corporation supports waste management solutions in Cambodia as well. GIZ, for instance, will soon start to implement 2 new programs that will focus on the reduction of single-use plastic and its litter into the rivers and into the ocean. And I would like to mention that the German government has designed specific support programs targeting pilot investments from the private sector, like the co-financing of pilot projects, co-financing of feasibility studies, or different support programs that are related to qualification and training. So on the next slide, you see the different sessions that we will host in the following days. So today, as already mentioned, we will focus on the topic of separation of waste. On Thursday afternoon, we will discuss or present the extended producer responsibility system. This is a policy approach under which the producer of packaging, for instance, they are giving us a specific responsibility for the disposal of waste. Then on Thursday afternoon again, we will have another session and we would like to discuss how hazardous waste can be treated in Cambodia. We also talked about that yesterday in the first session of the Waste Summit. And on Friday afternoon, we will present innovative concepts and smart collection products to improve the separation and collection of waste. I know that in Cambodia there is already some experience concerning smart bin, for instance. And then we will close the panel with the last session, which will focus on digital tools to somehow create awareness amongst the Cambodian society and the question of how the informal sector can be integrated as well. Well, as mentioned twice, actually it's really like an ideas generator, and we hope that we will develop some projects based on these sessions and on the matchmaking. I hope that we will have very interesting sessions, and I would like to hand over again to Black Forest Solutions. Thank you very much.
Thank you very much, Dr. Antid. Welcome again to all participants. We will now proceed with our speaker. He is Mr. Marc Loskarn from the Euwelle group, and he will share his expertise on mechanical and biological treatment, which is a very interesting technology applicable to Cambodia. Thank you, Marc. Very welcome, and the floor is yours.
So, hello, many thanks for the kind words, and also many thanks for all the organizers, especially you, Black Forest Solution. Many thanks for the opportunity and that we can speak here in Cambodia, so online in Cambodia, about this very important issue about waste collection and separation. So, can you see my screen? I think so.
Yes, thank you.
Yes, perfect. So, why doesn't it? Now, so my topics today are two at the moment. So I will just give you a short overview about the implementation of our maximum yield technology, which we are currently commissioning in Bangkok, Thailand. And I think this is pretty comparable within the waste composition in Cambodia. So this is could be important for you. And the second part is an overview of different mechanical biological treatment technologies. And it will end with a short movie which we have from one of our MBT plants in Egypt. So just that you can make you a picture on how such treatment facilities are working. So I will start with the maximum yield technology in Bangkok. Yesterday we had in another session a longer talk about the MYT technology, where I went a little bit more into detail. So I will here just briefly explain what the MYT technology means. So in general, and on a very rough scale here, it's just so it's a it has mechanical treatment as a first step. So where the recyclables and RDF, so plastics and high calorifics, are separated out from the organics. And the organics are here, which is in the special case here, in a two-step biological treatment method treated, where the organic is getting into the liquid phase, and the liquid phase and the solid phase are then separated and treated separately. So this is the special case here. I will go into it a little bit later. The project in Bangkok is containing lots of companies, as you see, and here local partners, the A2 Technology, Euwelle from China, so our parent company, and Esquare. We made a consortium together with Esquare to operate it. And we as Euwelle, as I am speaking here, we were responsible for the know-how transfer here. As you can see here, the technology is built a few times already all over the world. Here in Bangkok, it's a very large facility. Just to say, it's 800 tons a day, which is really large. But we are also able to make smaller plants. So I know Cambodia is a little bit smaller with regard to inhabitants and waste amounts. So we also have it for smaller scales. So here I think these details are important for you, because here the starting points are pretty comparable, because we have no separation at source of organic waste, so there is no separation at all. They are trying to involve separation at source in larger cities, but as we know it from people there, they are collecting it in different bins, but collecting it with one car. So they are mixing it back together, which makes a mixed solid waste at the end. So, and nothing is separated. It's just like some kind of greenwashing there. And the treatment is also not very good, because the majority is in open landfills, burning and incinerated, and mostly without energy recovery, and lots of littering into the environment. So I think in Cambodia it's pretty comparable at the moment, but I'm not sure about the fractions here, what is at the moment in Cambodia, if it's better or even worse. So a brief introduction about the location. As you can see, the facility is, as I said, quite large, but as you can see, it is really surrounded by green, by forests, and with inhabitants. So this is also perhaps an important point, because usually waste treatment is connected to smell, to odor, and to other emissions. But this technology is fully enclosed, and you will only see the waste once it arrives, and then you will not see it again. And this prevents odors and other emissions. As I said, it's also 800 tons per day, but we also have it in smaller scales. And here the waste composition is pretty usual for Asian countries. So you have quite half of it food and organics, then a quarter plastics and other packaging, papers, and other combinations here. And also you have, in case of Bangkok, a large fraction of bulky waste. So also small workshops are also putting their waste into the MSW, and everything arrives here. But this is no problem for this technology, as we separate it out. So this is a flowchart of the technology. I know this looks perhaps at the first a little bit complicated, but it isn't. Trust me. You can see here the total of the MYT technology is to be 5 steps. In Germany, we have all 5 steps, which we talked yesterday about. And the first step is here mechanical pretreatment, where you separate the high calorifics from the organics. Then you have the biological treatment of the organics and the anaerobic digestion. And other than in Bangkok, we put out step 4 and step 5 here, because the clients of our products, so we are producing different products from recyclables to RDF, and the client of the RDF was okay with the standard. The RDF comes out here already, so we do not need these 2 steps, and this was also cost saving here. So this is a rough mass balance here. So you can see here from 800 tons per day, which comes in, over 300 tons per day are getting out as RDF1, so-called. So the first fraction of RDF as fuels. Then we have 13 tons per day of metals. And of biological based RDF, we have close to 200 tons roughly. So you can see here as RDF, we have 500 tons out of 800 tons, which is over 60% we get RDF, and hence we have a product which we can sell. And here also biogas are over 40 tons per day, which are, this should be way more, over 35 norm cubics here, which we can also sell then for the gas grid, or directly produce electricity via combined heat and power and sell the electricity here. So this is the rough values here just for the calculations. And you can see it's complete autark here in case of electricity, because we are using here 1/3 of the produced electricity on our own, and 2/3 can be sold into the power grid. You can see that what is needed for such a plant. You can see here, of course, office buildings and the different halls, which I said. And you can also see that there is always also a workshop here. So everything will be built and maintenance here on site. And these are now some live pictures here because it's still commissioning, and we will start operating at full scale beginning next year. So this is just how it looks like at the moment. So this is the top view. As you can see here, for example, here are the enclosed conveyor belts. As I said, you won't see the waste again after it arrives here. And here is the arrival bunker. Here is a deep bunker in this case, but in Germany we also have flat bunkers. This is just case by case. And here the crane. And this is how it looks like on the inside. Here you have the pre-treatment and the drum screens, all fully enclosed, of course. And here are the MZR, so multiple zone reactors, where the first biological step takes place, where the organics are put or hydrolyzed into organic acids, so water soluble, and then a phase separation takes place here. Here is only a biogas tank. So this is a storage tank just to have always an equal power output. Yeah, and the summary of this technology is that it's an effective reduction of a waste amount, because when using all of the inert of all the energy, we are able to reduce the amount to be landfilled up to 95%. So this is especially important for countries or municipalities that don't have any more land for landfills. And also we prevent the leakage of landfill gas. So we are then producing methane in a technical way and collect it and use it as energy, as power. And this is fully ecological and economical of the energy content. So we really use everything what is in there, only the minerals which are then put for civil works or go back to landfill as inerts. So this was in the first part, and now I will get to a more easy technology, which is mechanical biological treatment without biogas production. So the biogas production step is here left out. Here we have pretty much the same flow chart, so the rough flow chart, sorry. Which here contains a mechanical pre-treatment. So here you have the same as we already said. It's shredding the waste on a defined upper corn so that it's flewable. Then we have the separation of metals, so recyclables. And here you have a screen, which is depending on waste input and the client. And with the screen size, you can just adjust the content of organics in the upper corn and the plastics in the organics. So depending on what your product is, the mesh size will be chosen. So you can see the upper size is mostly then RDF and high plastics, cardboards, other non-ferrous metals, and this will be sorted here by hand for recyclables or other usable materials, and then producing of RDF. And the undercorn, so the fines here, which are high in organic, are then treated aerobically, so no production of biogas, and then here the product will be produced. The products can be compost, can be also RDF, which are high in organics, or also soil improvers. Here you have some examples. So the mechanical treatment I already explained here. And the biological, so there are two different kinds which you can do for the biological treatment here. One of it is biological drying, which aims to the production of RDF, which is here the important part. And especially here within the contaminations, which are mainly plastics, are no problem, because the plastics are high in heating value. And this is, of course, good when you want to have RDF production here. It looks a little bit different when you really try to produce compost or soil improvers here, because lots of national legal frameworks prohibit the production of compost from MSW, because usually you are not able to really fulfill that there are less than 2% or 1% of plastics in there, and it's very expensive to do so, because you have to sieve it as at 10 millimeters or at 2 millimeters, which really takes a lot of time and energy here. And here you can see a comparison between the different biological treatment technologies. Here on the left side, you can see the most common one. So this is really often done all over the world. It's open heaps. So here, open heap composting, which is pretty easy. You have open heaps mostly on rural areas, because you have odors and other emissions here. And you can see here an aeration equipment, which just takes the waste over, just to get more air in it, that the biological microbiological bacterials can compost it. A little bit more advanced is membrane composting, especially in rainy and cold areas all over the world, because this makes the methodology a little bit less weather impact. And the highest technology here, so this is then the most important, but the way most effective is here box composting. So you have totally no impact of the weather. You have defined conditions. You have an active aeration and lots of measurements in it. And comparing these three technologies, you can see here, especially, the time needed for composting are 3 months to even over close to half a year. And for only drying, it's still more than 3 months here. With membrane composting, it's like the half. And for drying, it's only like 2 weeks to 3 weeks, depending, of course, of the input and weather conditions. And box composting really is like roughly 1 week, gets pretty dry for the drying, and composting is roughly 3 weeks. So box composting is, especially if you have large amounts of waste and only less area available, and open heap and membrane composting are the common used technologies here. And here you can see also in the area, and of course then the costs. The cost of box composting is of course higher, but you have a way larger throughput. So, as I said, we have built a MBT in Egypt, which looks like this here. The hard facts of this facility are the capacity, which is 35 tons per hour, which is depending on the shift model, of course. In this case, we have a 2-shift model here, and we have 500 tons per day. So this is, of course, very flexible. If you have a 1-shift model, then you have like 200 tons a day or even less, depending on the equipment, of course. The input is unseparated, so mixed municipal solid waste. And the products here are RDF, recyclables, so plastics, metals, and papers, so which are sent to recycling facilities here. And here we really have the case that we are also producing compost. So the product which is produced here after drying and composting is again sieved, and then the high organic fraction is sold as compost, and the high plastic fraction is sold as RDF. The video which I will show you now is not finally done because it has no text yet, so I will just tell you what you are seeing here. But it will be finished soon, so within the next 2 weeks, and then it is available on our YouTube channels if you are interested. The link is on the next page. So if you could just give me a short feedback if you can see the movie.
Yes, it does.
Perfect. I am not sure because it's pretty high quality. If it's like stop motion arriving at you on the important parts, I will just stop and explain what is visible. So, yeah. So here you can see the arrival and how it was built. This is in the top view of the total area of this facility. Of course, the arrival. Here you can see the crane who is putting the arrived waste into the trichter here, and this is in the shredder, which puts also the bulky waste with couches, sofas, tires into a defined particle size. Then the next step is the sieving, which you can see now. Here in this case we have a star screen, which is a bit different from a drum screen, but it really has a higher throughput and is better usable for MSW, because this handles the sticky waste better as a drum screen. Here you have the manual hand sorting, which is a positive sorting where they put out the high valuable recyclables. And here the different fractions. This is how it looks like within the open heaps. And this is an aeration equipment, which I said, it's like 1 or 2 times, depending on the weather conditions, of course, to aerate and to mix the waste again. And here you can also see for very hot conditions, it can be also here operated with water, that the dust emission is decreased. Here you can see, as I said right before, this is the product after composting, and even here you can see it's high in plastics. So this has to be separated again. So they're just putting here this products into a second shredder, and then here a sieve is where compost and plastics are separated, just for understanding. And for the operation of this plant, there are 12 people needed. So 12 employees are running this facility per shift. Here, this is the plastics and this is in the organics, which is here then final products. Here you have plastics baling and paper balings here, which are then sent to recycling facilities. Yeah, and this is just the carpool which is needed for such a facility. Yeah. So this was my presentation for today. I want to say thank you all the participants, and I hope you have lots of questions and I help you where I can. And also thank you to the Black Forest Solution team.
Thank you very much. It's been a very interesting session. You said before, the situation in Cambodia might vary to other countries, but in the end, microorganisms work in the same way everywhere, and
yeah,
it's pretty applicable anywhere, right?
Yeah.
Also, thank you for sharing the video. It's very helpful to see step by step what kind of requirements are needed. Even if it's not ready yet, it was very helpful. Thank you, and we'll be sure to see the final product in the next coming weeks. We do have a couple of questions in the chat. So the first is related to cooperation partners. In the development of the plants, do you work with local organizations usually?
Yeah, usually we have local partners there who come to us, and usually we are only a technology supplier. So the operating of such plants are usually done by local partners. So we do workshops there that the people can handle it by themselves. So it's really not rocket science. And the technology, even if it looks, especially at the MYT technology, which really looks high ambitious, it's pretty easy to handle. Of course, you have lots of measurements and monitoring there, but at the end, it's still simple mechanical treatment and biological treatment. So usually we are not the operator of facilities, but technology suppliers. So at the moment, in the example in Bangkok, we have, as you've seen on the very beginning, we have a consortium made with Esquare, and we only have, I think, at the moment 2 or 3 people from Euwelle there who are really training them that they can operate it by themselves.
Okay, understood. Thank you. Mr. Sokos, I hope this answers your question. If not, feel free to follow up in the chat. We have an additional question regarding financing of MYT, of the MYT plant in Thailand, whether this was realized through a tender project.
Yeah. And this was tendered by Bangkok municipality, but I'm not sure at the moment about the details about this project. I'm sorry.
No problem. Perhaps then expand on the business model of the plant itself. So what about the revenues related to the residue-derived fuel or the biogas that leads to electricity production?
Our main product is, of course, here RDF, so refuse-derived fuel, and our main client for this is the cement industry in Thailand. So there are, we have a contract with the largest cement company in Thailand here, and we are delivering to different locations of this company. And the electricity produced here is directly set into the power grid, and we get, of course, also a fee for it. So a defined revenue for each kilowatt. And this is fully economically here. It really works on its own, yeah.
Okay, I can also imagine that the other fractions that you recover as metals and paper.
Yeah, but this is only here in Bangkok a small fraction, because you also have here the Scavengers, who are, of course, aiming for the cherry picking, of course, which is then aiming for electronic waste and the metallic waste, so copper, aluminium, iron, everything, and they are just picking it before it arrives at our facility. So it is not as in Germany, like 3 to 5%. It's way less here in Bangkok.
Okay, so perhaps if such a plant were to be built up in Cambodia, it would need to be observed then which streams would actually arrive in the plant.
Exactly, but it's everything is possible. Also, without the metals, it's still suitable, and it still makes sense to separate the plastics from the organics and make use of both, because it's always better to have it dumped in a landfill as a mixed waste. Because, as I already said, the production of methane is a really large problem all over the world, if you see it as a whole. So I think only the separation of plastics and organics already makes a lot of sense and is suitable economically.
Yes, correct. And also particularly relevant for Cambodia, where a high proportion of municipal solid waste is organic.
Exactly.
So the follow-up question of Mr. Chen, Sokos Chen, is whether there is an organization in particular that you work together with in Cambodia.
Not yet. We have our eyes open, as we are very active in the Southeast Asia. We are active in Vietnam already. We are active, as you've seen, in Bangkok. And we are having our eyes and ears open to all of the countries, especially since China closed its borders regarding the import of plastic. And I know lots of new countries have now a waste problem, especially with plastics. So here a separation at the dump sites could really improve the situation for the people living there and especially for the environment. So this is really a high important topic here.
Okay, good to know. Thank you. As a short reminder to all participants, please feel welcome to take note of contact information. We'll be happy to organize B2B sessions additional to this panel, if you can think of cooperation ideas. Another question was related to investors, what they could expect, cost duration, return of investment.
This is highly depending on our first investigation. Also, usually we make a feasibility study at the beginning. So we are active in very different countries, so all over Africa, Europe, Asia, and we have to get really reliable data from each area, region, even city, because waste is not even equal to waste. And our financial plan is really depending on the input. So as you can imagine, when we are calculating with 50% of organics and then calculating the biogas production, hence a revenue from the power production, and if you have only like 10% less, it's like 20% less of power production, and this can really affect our plans here. So it's really important, doesn't matter where we are, just to make a feasibility study to get reliable data here. From the input, from the revenues, from we need really also secured revenues here for certain time. And then it's usually we'll find a way.
Okay, thank you very much. We're a couple of minutes past the time. I hope this is okay with everyone. We only have very few questions left. One of them is from Mr. or Miss Sokling Weng. Excuse me. What are the challenges that you have faced when you started the project in Thailand?
This was funny, exactly which I already said yet, because of the reliable data. We had feasibility studies there a few years ago, and we really had our calculations based on it. And now, while commissioning and getting the first amounts of waste, we are not sure yet if it's statistically seasonal fluctuations here, but we have a really high fraction of bulky waste here, which we didn't expect. So there are really large particles which have to be sorted out at the very beginning, which we didn't calculate with, and we had just to adapt one equipment more, but this was then no problem at the end. But yeah, there are always things where you can't don't find the word at the moment. You can calculate everything, but there are always new stuff which you can't really put into your calculations. So in Thailand, as I said, the bulky waste, and it is of course pretty hard to coordinate all the companies that are working together, which is a management problem. But at the moment it's working, and we hope to get it started until next year.
Hopefully, yes, as with any project, there are many unforeseeable events.
Exactly, yeah.
Correct. I hope this answered everybody's questions. I don't see any more in the chat. Okay, if there are no more, I would like to state again, Please feel welcome to contact the organizers and take note of the email so that we can talk about possible collaboration or learn more about each other's projects. Thank you all very, very much for participating and taking part in this second day of the summit. Thank you again to the organizers and our honored guests. It will be possible to have a look at today's presentation. It will be available either on the website or you will receive it on your email after the 5th day of the summit. Thank you all very much again. Thank you, Marc, again.
Thank you too.
And wish you all a pleasant afternoon.
Thank you for participating. See you.